Now, I'm not sure what question this is, but I want to go over this one because I think this is really important. And the reason that this is important is because it makes you do several different things for comparison analysis. And these are the ways some AP questions are going to be asked. They're going to give you a lot of strange data, and you got to figure out how to make it connect to then compare it. Okay. So, which would provide more grams of NaCl? A sample with one mass of 2,335 milligrams. Now, I know it's kind of weird. There's a space here, but sometimes when you do these things, they just leave the commas out. Or a sample 2, a solid with a volume of 2 cubic centimeters, and then it tells you the density of salt. Excuse me. Sorry, I'm thinking. The density of solid salt is 2.16 grams per cubic centimeter. Report your choice in the grams of the more massive sample. So I'm going to come off of this page and help me out. It said it was 2,350 grams, right? Why did I say that? I meant milligrams. Okay, so we've got milligrams. Now, you're going to have to do this, and I hope at this point you know this. This is a basic skill that I expect all of you to have. Okay, this is a basic skill that I expect all of you to have, right? Okay, now, what unit was it given in? Milliliters, and we're going to what? Grams. So 1, 2, 3 to the left, and it was 2,350. So we need to roll it 1, 2, 3. So it's equal to 2.35 grams, correct? Now, where did the 0 go at the end of that thing? Very good. There's only 3 significant figures. So do I need the 0 after that 5? No. So you can just drop it and get rid of it. So we've got 2.35 grams. Now let's look at the other one. I am going to need your help. How many? What was the volume? What? Okay. So 2 cubic centimeters. What's up? Right now, what books? I need to know what book. What book? Go ask her. What book? Okay. Now, what's the density? Mason, what's the density? All right. So they've given you 2 things. Thank you. That does mean a lot. Okay. Now, what type of unit is that top one? It is volume. Is that important to know? This next one is obviously density because they tell you that. Okay. So I've got to figure out how do I get density and volume, because how can we only compare these 2 pieces of data they gave us? They said put it in what? They said put it in grams, right? Now, here's the deal. Do I have 2 units that match that I could possibly get rid of? Yes. And is the only other one left, is it something that I can use? Yes. Now, so we need density, and density is what? Okay, or density is mass divided by volume. Now, so Mason, this should make more sense. What am I trying to find out of this thing? Mason, what am I trying to find? So what do I do? Does this make sense? Okay, so what do I do to these 2 numbers right here? Multiply them. So what is 2.00 times 2.16? Say it again. 4.32 grams. Well, that's really simple. I've got 4.32 grams versus 2.35 grams. So if we go back and we look at our answer choices, what's your answer? The answer to the question is number 2, which is sample 2. Now, somebody said a minute ago, I hate AP questions because of what? What was the reason I heard that kind of tailed off? Okay, why does 3 and 4 bother you? I know it's not the right answer. I'm trying to learn from you guys. plus or minus 1. Yes, I agree with you. If sample 1 were the right answer, which one would you have selected? You would have to select 3 because of the significant figures. Okay? Yes, sir. Assume. Because which would provide more grams? A sample 1 with that. You would just assume that because they said it's salt, you assume they're both salt. I know that is kind of worded a little strange, but that is what it is. And the reason, are you glad I went through the density part? I just want to make sure we're on the same page. Okay? All right. Okay. The next one. The following balanced equation shows the reaction between zinc and sulfur to form zinc sulfide. Now, this is something you guys may have never seen before. That's not what I'm wanting you to do. I'm wanting you to look at this. This right here looks a little odd. What is that kinda like? It's kind of like a diatomic, right? But why is it not a diatomic? Di means 2. This has a specific name called an allotrope. And I've talked about this before. S8 is very happy, and P also forms one of these. What is P? P4. S8, P4. The way I remember it is S, can you turn an S into an 8? That's how I remember it. An S can turn into an 8, and a P, P4, I don't know. It just kind of sounds right. Yeah, take off the top of the P. I like that. So if I take off the top of the P, it kind of looks like a backwards 4. I like that. That makes sense. Say that again. No. Well, okay, that's a great question. Let's answer her question because it's a great question. If it says solid pure sulfur, is there any other element with that? No. So it's solid pure sulfur, S8. Exact same concept. If I say oxygen gas, is there anything else there? So it's O2. Same concept. Does that help? Okay. When it's in an ionic compound. Yes. Yep. Okay. So the following balanced equation shows a reaction between zinc and sulfur to form zinc sulfide. If you began the reaction with 15 grams of zinc and 10 grams of S8, what is the maximum number of moles you would obtain? Now I want to pause for a second. I want to go back for a second. That would help if I had it right. Why are there no subscripts in that formula? Check the charge is very good. And zinc is always a what? 2 positive, and sulfur's in group 16, so it's a 2 negative. Does that help? Okay? All right. Now, so here's the deal. They tell us, and I like doing this. I'm one of those, I'm a visual kind of guy. I need to see it. They tell us that we have 15 grams of this stuff, 15.0 grams. And they tell us that we have 10.0 grams of this stuff. Yes. Let's give them the old ones if we can get in that room. Do you have any of the new ones? Perfect. Yes, give them 3. Is it biology? Okay, because she didn't tell me which book, so I didn't know what book she was talking about. Gotcha. Thank you. Now, and we're trying to go to what? We're trying to go to moles of this stuff. There's an important question here, and let me pick someone to ask this question to. Do not answer this question out loud, Tristan or Justin. Ryan Howard. Which one of those do I pick? Which compound, the zinc or the sulfur, do I convert to zinc sulfide? Don't help me. Elizabeth? Very good. That thing. Okay. But you don't know that yet. Okay. So, you would think. Okay. So we need to find the limiting reactant, which is moles over coefficient. Now, one of them is really easy. One of them's simple. So if I've got 15.0 grams of zinc, and I want to know grams to moles of zinc, so in 1 mole zinc is, okay, 65.39. That's real easy. Go ahead and give me the moles since we're here. Give me 3 sig figs. Okay. All right. So that's moles of zinc. And then the other one is really challenging and it's aggravating because it says 10.0 grams of S8. What makes that more complicated? You got to multiply 32.06 times 8. Okay. It is a lot and it's aggravating. What is that? $32.06 times 8? If you did that in your head, that's really impressive. That's really impressive. 256 point what? Wow. Dustin, that really is impressive. I'm not going to lie. Bro, you're smarter than I am. Okay. All right. Rather, and as a science teacher, as a chemistry teacher, I should be able to do that, but that's on a totally different level. All right, Justin, what's the moles on this thing? Now, here's the deal. We're all cool and we're all grand, and you can say, okay, well, I know what the least is, but there's one more step we got to take. And we do need to take that step because we're not quite sure, unless you're Dustin, if you know that this is going to make this true or not. What do we have to divide the zinc by? Which is 8. And what do we divide by the sulfur by? 1. So we need to make sure that if you divide the moles of zinc by 8, that it doesn't make it less. When you divide 0.229 divided by 8, does it make it less? Yes, okay. Now tell me what it is, just so we'll know. Can y'all see that? .268? 286. Okay, so we now know that is the least, so that tells me that zinc is my LR. Okay, zinc is now my LR. Right, Howard, I'll come back to you. Okay, now we know which one we're going to use. Which one we're going to use? The zinc, and I'm converting to zinc sulfide, right? So what unit am I converting from and to? Moles to moles. Now, here's the good news. What color is my moles of zinc already in? Green. So let's keep that number. So we're going to go 0.229 moles of zinc. Now, what's the good news about the answer? How many steps do I need? 1. So I'm going moles of Zn to moles of ZnS. And what is your mole to mole ratio? Well, that's real fancy. That is kind of wild. Go ahead. Now, pause there. When it gives you two amounts that are both reactants. Okay? Because think about this. What is a limiting reactant? It's the reactant that runs out first. Well, if they give you a reactant and a product, that doesn't work, right? So if when we're using limiting reactant, it's got to be two reactant amounts. Does that make sense? Bingo. Yep. And the only reason we had to do the limiting reactant part was because they gave us two starting amounts. And the reason we had to convert the grams to moles is because to find the limiting reactant is moles divided by coefficient. And this part is converting the limiting reactant to whatever we're trying to find. And you have to do a mole to mole to get from one thing to something else. Okay? All right. So we go to the next one. The amount of tungsten metal used to make many light bulb filaments, starting with 25 grams of, what is that name? Be very careful here. It is tungsten 6. So, here's the deal. If I want to know what the name of this thing is, stay with me. Stay with me. If I pull back, I get a 3 plus and a let's try this right. -1. Is that right or wrong? That is wrong. This needs to be all multiplied by 2 because that's what I need there. So -2 and +6. Madison, does that make sense? Stay with me. Pause. I'm talking to Madison. Do you agree when I pull back I got a 3? When I pull back I got a 1. Oxygen has to be what charge and why? What group is it in? Got to be -2. Why? It's in group 16. So what you do is you multiply both that, just like math. What you do to one side, you got to do to the other. Okay, you got to multiply both of these values by what you need that thing to be. Does that make sense? So we need it to be a 2. Multiply it by 2. Well, you got to do it to the other side. So -2 and then +6. Does that make sense? It's real quick, but it's basic math. Yes. Roman numeral is VI. Yes. Okay. We're starting with 25 grams of tungsten 6 oxide, in which the following reaction was 18 grams. Starting with 25 grams of tungsten 6 oxide in the following reaction was 18 grams. Does that make sense? Hold on. Here's what it is. The amount of tungsten metal in the following reaction was 18 grams. Does that make sense? We're starting with 25 grams of this stuff, and I want to know how many grams of that stuff is theoretically possibly made. This is a terribly worded question. It is. I promise you, questions that I'm going to give you are not worded this poorly. We're trying to figure out the percent yield. So let's start there. What is percent yield? Very good. Actual over theoretical. Hang on. Of the two, which one have they already given you? Now, before you answer that question, what are we trying to find the percent yield of? The tungsten. How much tungsten did they actually get? 18 grams. Well, the problem is we need to find the theoretical. Can we find the theoretical based on the rest of the stuff they've given us? Yes, because we've got to get from the 25 grams of tungsten 6 oxide to just tungsten. Now, if I had said in a very elementary way, you have 25 grams of tungsten 6 oxide, how many grams of tungsten are there? Could you have done that? That's an easy equation. What do? Stoichiometry. You stoic it up. Gram to gram. Okay, so let's do that. Okay, I'm going to need some numbers. That's fine. I'm going to need some numbers. So 25 grams of WO3. We got grams of WO3 to moles. And then I'm going mole of WO3 to mole of just W. And then mole of just W to grams of just W. The first thing I need from you is the mass of just W. 183 point what? 85. Now, I need the mass for the tungsten 6 oxide. Chance. 231.85. Now, I know that this is a 1, I know this is a 1. Before I fill out the middle, I'm going to pause for just a second. And I'm going to let you catch up, and then I'm going to ask a follow-up question. Do you all agree this is just a basic gram-to-gram stoic? Okay? Now, here's my question, and then we've got to do something about it. Where does my middle step come from? So let's go back and let's look for just a second. Is that thing already balanced for us? Yes, that's great news for us. What is our mole-to-mole ratio? 1 to 1. So mathematically in our calculators, does this step have any numerical effect? Not at all. Okay? Chance, so what did you get for an answer? 19.8 grams. And I'll come back over here and do this. So 19.8 grams of W. So this is our theoretical. In theory, If I gave you 25 grams of tungsten 6 oxide, you should make how much? 19.8 grams of tungsten. Now, that's if everything goes perfectly, right? You make no mistakes. How often does that happen? Never, okay? In real life, I don't know. These are just made things up. So now we need the percent yield. Now, percents are part over whole, right? But a percent yield is an actual over theoretical. So we actually got 18. We should have got 19.8. So what's our percentage? 90.9%. Would you take that today? I sure would. Now, obviously, if you calculate 90.9, if 90.8 is on there, don't be an idiot. Don't choose number 4. Don't say, well, it's not perfect. Well, duh, it's not perfect. People round differently. Yes, get it close. No. That's just as bad as doing the other two. Yes. For people that are dumb to say, well, that doesn't match my numbers. That can't be right. It doesn't matter. People are dumb and they'll put that. You know what would really happen? People are going to read this question and say, I have no freaking clue what this means. So guess what they're going to do? Circle 4. Okay? Jamila? Now, I'm not going to lie, Mason. It is rare, and I mean rarely rare, for them to have there's not enough information, something along those lines that actually is the answer choice. That's what I'm saying. Yeah. So actual is 18 divided by 19.8, which is theoretical. Yep. Yes, sir. Yes. Yes. Yeah. Yeah. But there are some that are all are correct, all are incorrect, stuff like that. Now, but I will tell you this. Mathematically, is it possible to get 110%? Experimentally, it is possible. If you screw it up bad enough. It's possible. You could actually think about that. If you accidentally put more stuff in than just the tungsten, isn't that going to make your actual go up? Your theoretical is still going to stay, the math is going to stay wrong. So you, in theory, could get more than 100%, but that's really wrong. Stop. Nope. We're not going there. All right, so that's it for that one. So what I need you to go to next is the other multiple choice that I just gave you. All right, so what this is there's a group out there that is called Laying the Foundation, and they put out their resources and they do a lot of different things. So what we're going to do is this is the chemistry diagnostic test. Now, diagnostic is pre-content. This is what you see how well you could do it. So you should already know how to do most of this stuff, okay? But I think it's a really good indication of how to do it. Now, to be honest with you, this used to be a style question on the AP exam. It is no longer a style of a question where they give you information, and question 1 through 5 was associated to all that information. All the questions are now independent of each other. Say that again? No. You know what? What I just said is incorrect. I retract that statement. How did they used to have them? We'll come across them later, so ignore what I just said. There's a format, there's a style format of question that's no longer on there, and I can't remember exactly what it looks like. Nicole? Yes, if you want to do it for practice. Okay. All right, so questions 1 through 3. If 0.25 moles of this compound has a molar mass of 10 grams, 0.25. Yes. It's A, B, C, D, or E. A quarter of this compound has a molar mass? It's a fourth. So what is it? E. Does that make sense? Look at E. So here's where we want to start. What is the definition of molar mass? So, I have so many grams for every how many moles? 1 mole. So NaOH, if I have 1 mole of it, how much does it weigh? 40. Question 1 says, I have a quarter of a mole, and it weighs 10. What's a quarter of 40? 10. Does that make sense? Ten plus 10 plus 10 plus 10. Okay. All right, 22 grams of this compound will contain 6.02 times 10 to the 23rd atoms of what? That's very important that you catch that. First of all, if we have that many atoms, how many moles is that? Justin? Okay. So let's look at the key. So it'll make it a little bit clearer. The correct answer is C. There's your math. "22 grams of carbon dioxide." We went to mole. What is 22 times 2? 44. Would that be 1 mole of carbon dioxide? Yes. All right, well, I have half of the total mass, but I have 2 atoms to cover the half. Okay? All right. 1 mole of carbon dioxide is 44, but I only have half of that. I only got 22. But how many atoms of oxygen are in carbon dioxide? Well, if I have 1 of them, that's 22. If I have another one, that's another 22. Does that make up the difference of 44? That's where it comes from. These are a little harder, aren't they? Okay. Because what was the question? Is asking about oxygen. Well, here's exact. It is with carbon, but this says 22 grams of this compound. So it's half the mass, right? Yes. Yeah. You with me? Just. Well. All right. Number 3, the substance that contains the highest percentage of oxygen. Be very careful here. Can you automatically jump on the one that has the most oxygens? No, you cannot. Okay. So let's think about it. Would you 11 out of 342? Well, you've got 12 carbons. That makes the difference, right? That's almost 50-50. And then you got to include the 22 hydrogen, so that brings it down even more, right? Okay. Calcium sulfate. You've got what? Calcium is 40, sulfur is 32, and you've only got 4 oxygens. That pulls it down, right? And it's not going to be the highest. Carbon dioxide, but the one that has the highest percentage. We'll look at D. That one makes logical sense, I would hope. Because hydrogens, you've got two hydrogens at 2.02 apiece. And what is the oxygen? 16 of 18? That's significant. 89%. Matt, does that make sense? You sure? Okay. All right, let's go to the next one. Number 4. Each of the questions or incomplete statements below, followed by 5 suggested answers or completion. Select one that is the best in each case. So the mass of 1.24 times 10 to the 24th atoms of hydrogen gas is equal to. Now, so we're going from atoms to what? Grams. So I've got 1.204 times 10 to the 24th atoms. Now, and I taught this a long time ago, and I'm only going to say this once, and I'm going to say it here today. If I want to fly to New York City right now, can I go out to the Dothan International Airport? That's a joke, by the way. International Airport. Okay. Jump on an airplane and fly myself to New York City. No, I cannot. Okay, if I have a private jet, we're not talking private, we're talking really expensive. Where do I have to stop? Well, I got to stop in Atlanta. So here's how we can talk about this. This is grams, and I'm trying to get to atoms. Is there anything in between it? Obviously, it doesn't matter what end you start on. Are you still going to and from? Once you go to New York, I hope you're coming home. It's actually a cool place. You may want to stay. It is a really cool place. So, it does get really cold. And in the summer, it's really hot and it smells like urine. Alright, so here's the deal. This is what we got. So if I've got 1 mole and 1 mole, how many atoms are in 1 mole? .02 times 10 to the 23rd. Now, here's the tricky part. What's your mass? Why is it not 1? Fan-friggin-tastic. Hydrogen gas is what compound? H2. That's what's going to get folks. You know what I'd be willing to bet? That one of your answer choices is half the right answer. Here's the next part that scares me. That step number 1 is that you're going to put 1.01. That's the first thing that scares me. Number 2 is a mechanical issue. Can you actually do that in your calculator? That's the part that scares me, is that you don't know how to do this in your calculator. You do know how to do scientific notation like that. Alright, right above your number 7. Do you see a button that says 2 little blue buttons or green buttons that say EE? Right above 7. Or is it just straight EE? Show it to me. Yeah, so you have to hit second, then EE, right? Alright, so here's what I want you to do. Type in, and this is important. We're doing this today and today only because I want to make sure that you guys can do this. Because if you can't do this in your calculator, you're going to have a long, hard year. So put in 1.204, and I need my Wabbit up here. My Wabbit. That calculator, that fancy one I used to have, remember? It's called a Wabbit. It's called a Wabbit emulator. So 1.204, and if you may have to hit the second button and then EE, but this is what it should look like in your calculator. It should be 1.204 with a capital E, and then it will be 24. That E is the exact same thing as times 10 to the. That's what it represents. It's exponent. EE is expanded exponential. Regular 24. Now, go ahead and double it. Multiply it times 2.02. Esteban. Calm down. Then, divided by Avogadro's number. 6.02 second EE 23. That's when we're trying to find the number of H's within a singular compound, such as glucose, C6H12O6. If I want to know something about the number of hydrogens in glucose, it's one hydrogen. Does that help? Okay. All right, so what answer did you guys get? Okay. If you had 1.01, what answer do you think you're going to get? So is it important that you catch that? And I'm telling you, the way they design these multiple choice questions is they, based on research and data, know where students mess up their calculations. They incorrectly, on purpose, calculate answers, get those values, and plug them in. So what happens is if you do it wrong, by magic, your answer shows up. It's dirty, but they do it that way. Okay? Exactly. What would I do if I was taking this test and incorrectly calculate an answer? And they take those answers and they give them as answer choices. Yes. In terms of they're wanting to see, they're wanting to know, are you doing it right or are you doing it wrong? And what happens, Justin, the reason they do this is for statistical purposes. If you choose that answer choice that's wrong, they know what you did. And they know that, okay, we have this many percentage of students doing this problem wrong, and we know how they're doing it wrong. And they can kind of build teacher trainings around, these are the errors we see, and here's how to fix those errors. And it makes sense. You're like, well, that's good teaching strategies. How can we fix the errors that students commonly make? So it really is a good way to do it. I just don't have enough time in my day to make your test like that. This is what people are paid daily to do those things. Okay. Heck no. Yes. Yes. Way more than I do. Way. Yes, absolutely. In fact, I graded a little harder, and the reason why is because if I grade harder, your expectations are up here. Well, when you take the test, where your expectations already are, they're a little less than that. So if you make some sort of mistake, there's that gap. Does that make sense? So it actually pushes you to be better than you actually have to be in some cases. Now, this next question is a doozy. It's a doozy. Yeah, last year. A hydrocarbon is found to have an empirical formula of CH2. Let's stop there. Do we know what a hydrocarbon is? It has a hydrogen and a carbon. Do we know what an empirical formula is? What? The simplest whole number ratio. Okay? The simplest whole number ratio. I'm actually going to throw a curveball at you guys. Please do not say this out loud. I want you to actually write it down. Above the name of that compound, write its name. CH2. This is throwing it way back. I want to see if you remember organic nomenclature. Shh. Shh. Do I want to ask it or write it? I'm not finished. Is that the first part? Why is that the first part? How many carbons do we have? One and prefix, one is meth. Now the ending part is okay. Pause for just a second. All right. Remember, if it's all single bonds, it's double the hydrogen plus. Excuse me. It's double the hydrogen plus 2 for all single bonds, and that ends in ane. For double bonds, it's double the carbon. That's it. Okay. For triple bonds, it's double the carbon minus 2. You with me? Did I just mess this up, didn't I? Hold on, hold on, I did mess that up. What an idiot. That's it right there. It is ene. My apologies. 2n plus 2. Double carbon plus 2. Alright, so let's actually get into the problem. Its density, whoa, that's kind of weird, at STP, that's even weirder, is 2.5 grams per liter. And then it says, what is its molecular formula? What in the heck? They tell us an empirical. They talk about density of the STP, and they say, what's the molecular? Let's talk about what we know. First of all, what is a molecular formula? It's the actual compound and actual formula. Do we have a formula to solve for the molecular? Do we have a calculation? Okay, remember, it's the mass of the MF over the mass of the EF. Is it any more complicated than that in the basic sense of the level? That's the question. We need the empirical formula, right? And we have to start here to be able to get there. Do we have one of those numbers? Yeah, you have to do a small calculation. Which one do we have? EF. What is the mass of CH2? You're right, 14.03. 12.01 plus 2.02. 14, but nitrogen's 14.01. Oh, you're saying you get the 12 and 14 mixed up. Gotcha, okay. So here's the next part. We've got to figure out the mass of the MF. Now, they give you something very important. They give you the density of this thing, true or false. And they tell you something about STP. So, let's talk about this. Tristan, go ahead. Yes, you can stand up. Okay. Normally, yes. We're doing it backwards. Yes, we're doing it backwards this time. Okay. All right, so here's the deal. T is what at STP? What is the value? I know I'm not talking. I'm not. Hold on. I'm asking a question here. What is N? Which is how many at STP? These are your 4 STP things that you have to have. And I know what you're thinking. I can see your wheels spinning. And yes, you didn't do it quite right. We're going to get there. It's okay. That's okay. He knows what he did wrong now. Don't you? Keep that to yourself. So here's the deal. We've got these 3 things. Did they give you any of these variables or values in the question? They gave you all of them. Yes, they did. Stop. They gave you every single one of those values because they said at STP. Oh, stop. But here's the problem. What numerical thing did they give you? They gave you density. Stop talking about people's mamas. Okay? Do you agree that this is the thing that we need? We've got to have that. So let's talk about our kitty cats. So, I promise I'll go right back. So here's the deal. Anytime we're dealing with something like this, when they give you density and you need to get a molar mass, You've got to use some dirt over some P. Okay? So let me go back. I was requested to go back. So here's back. And the reason I asked that question is, did they give you any of these variables? The answer to that question is yes. And I know that is a difficult concept, but let's be honest. This is something that instead of them having to write all of that junk in the question, they have standardized their approach and said, if we say letters S, T, and P, you know 4 things. Okay? It's making an approach a lot easier. Question. Don't go in it. Don't go ahead of me. Okay? Stay behind me. Okay? Go ahead. Yes. Potentially, yes. There's a high chance that you're going to use some sort of variation of that, yes. What is the other variable they gave you? Did they give you grams, or did they give you moles, or did they give you density? Does that make sense? Had they given us grams, more than likely, I'm not going to say 100%, but more than likely, yes. And which one you would pick is dependent upon the other value they gave you. Because you can't just say at STP. Well, something else has to be told. Yes, gotcha. Okay, Mason, don't go ahead of me. Okay. In this problem, no. You don't need moles in this problem. Simply because what's the other factor they gave you in the question? Density. So you need the dirt over P. Sir? Yes. Yes, ma'am. So here's the deal. Let's actually go back and look. Or you agree that we're looking for the mass of the molecular formula? The formula that the equation we just realized we have to use is molar mass equals dirt over P. So when I plug all my numbers in, this that I'm going to get is the molar mass of the MF. That's what we're going to plug in on top. Now, the reason I know that I'm solving for the molar mass is because it's right here. It says that its density is that. Like it's telling you the formula is density. Does that make sense? Okay. All right. So let's run over here and let's play with these numbers. So what's the density? 2.5. Okay. So 2.5 grams per liter. Very good. Now, your R unit. Does it matter which R you use? As long as your pressure unit matches your R unit. Now, which one would I prefer to use? Because let's actually jump on this. I've got 2 options for pressure. Would you rather have a number on bottom or a 1 on bottom? Let's put that 1 down there. So if my bottom is atmospheres, then which R must I have to use? The atmosphere R, right? We cool with that? 1. Somebody had a question. Does it make sense why we're using that R? Could you have done the 760 torr on bottom and used the torr R, but would that have made your calculation more complicated? Yeah, let's use that 1. Let's use 1s and we can use 1s. Now the last thing we've got to use is temperature. Which temperature? Because you've got 2 possible ones. Why does it have to be Kelvin? It's in this unit. We got to cancel it. So 273 Kelvin. Now again, I like to do this. I like to come in. I like to make sure all my units. What happens to my units? Okay. Is there anything to get rid of grams? Nope. Is there anything to get rid of liters? Yep. So liters goes. Does atmospheres goes? Yes. Does mole go? Kelvin. Does it go? So technically, what we're now left with is gram over mole. What is the unit for molar mass? Gram per mole. We cool with that? What's our molar mass value? Anybody got it? Zero 3? Sir. I don't want to hear that. I don't want to hear it. I don't want to hear it. I want to stay on this track. I don't want to hear it then. I'm not trying to be rude, but I don't want to break trend. Great question. Absolutely fantastic question. What do we need to do with that 56.03? Get rid of that 03. Great question. Now, actually, that's fine. Let's do that. If you now, Matt, I'm just going to throw this up here in a different color. Would it make it prettier like that? It would, but it doesn't really matter. We're just looking for a tenth off of a whole number, right? So when you divide 56 by 14, what do you get? 4. 3.9, which is 4. Now, I come over here, and I don't see an answer choice of 4. Why is that not? What's the question? What is that word? It's got to be a formula. So how do you get the answer? Multiply. So it's going to be C4H what? Answer choice B. I'm glad. As long as you get the right answer, you're in your own world. And that's why I like to. There are right ways and other ways, and I prefer the right way. Yeah. Perfect. All right. So number 6, hydrogen and oxygen gas react to form water. How many grams of each reactant are necessary to produce 36 grams of water? Is it easy? Esteban, talk it out. You sure? Now, what is my first question? My first question is water is what to what? So do you agree that for every 2 hydrogens, we need 1 oxygen? Okay, go ahead. It is? You sure about that? Okay. So, what is 18 times 2? 36. But if I do 18 times 2, that's 36, but that's my total. Where's all my hydrogens? Okay. Let's look and see what the key says just to make sure. Answer choice is B. Okay. No, that's what number are we on? My bad, I was on the wrong one. That's what I was fixing. I was thinking C was right. I don't know why. So, it is C. Because if you have 32 grams plus 4 grams, that's 36. Okay? So if you have, what did I say earlier? 16. I'm an idiot. Wait a second. Yes. Hold on, bro. So I asked a question a second ago, and y'all said 36, and I was like, that's not right. What's 16 plus 16? 32. What did I ask? The heck am I talking about? Why did I say that? So if we know that oxygen is 16, we know that oxygen. So two oxygens is what? 32. All right. Well, and for every 1 oxygen, I need how many hydrogens? Okay. Well, if I have 2 oxygens, I need how many hydrogens? 4. Well, what is 4 hydrogens? 4.04. Does that make sense? So, right here, the first question says the total has to be 36 grams, right? What is 2 plus 1? Well, that's a stupid answer. What's 4 plus 16? That's a stupid answer. What's 4 plus 32? Well, that's plausible. What about 18 plus 18? Okay, so that's plausible. 36 plus 36. You only have 2 possible answer choices, true or false. But here's the deal. Why can it not be 18 of hydrogen and 18 of oxygen? the ratio has to be held true as well. Stop it. It would be that. We don't talk about the... There's no such hose in chemistry. All right. So now that we look at it from that perspective, did it get much easier? A lot easier, right? Okay, good deal. All right. All of the following are empirical formulas except... Now, here's what I want you to do. Look at it, and with your hand, 1 is A, 2 is B, 3 is C. Which of the following... All of the following are empirical formulas except... Show me with your fingers what you would say your answer choice was. All right, I should see a 2 up. Okay, why is 2 the right answer? It can be reduced. Spectacular. Okay. All right, question 8. Production of carbon dioxide from its elements in their standard states. Now let's talk about this. This is important. From its elements in their standard state. Do you agree this is what it kind of looks like on the periodic table and then floating around in nature? Okay, carbon is a solid thing in nature, but why all of a sudden did that 2 show up on that oxygen? Just diatomic, fantastic. 6 grams of carbon reacted sufficient with oxygen. This is a new word that we've never seen. When it says sufficient oxygen, what did that tell you about oxygen? It is excess. So is that great news for us? Woo, woo! Yep, okay. 6 grams of carbon reacted to produce 11 grams of carbon dioxide. Which of the following best represents the percent yield? Again, this comes back to a simple question. What is percent yield by formula? Actual over theoretical. This number, we're trying to find the percent yield of this reaction. We're trying to find yield. Yield, yield, yield. Yield is a product. What does that arrow stand for? Yield. So that 11 grams of carbon dioxide is what you actually got, or theoretically what you got? It's what you actually got. So 11 grams. Now here's the challenging part. How do you calculate your theoretical? You got to stoic it up, right? Okay, get stoic. We got to go from 6 grams of carbon to grams of carbon dioxide. So I'm going to tell you how to do this in your calculator without even writing it down. First question is, what's your mole to mole? 1 to 1. So is that going to affect our math? So I know that I need to multiply 6 times 44.01. Where in the world did 44.01 come from? That's the mass of carbon dioxide. So all across the top, I've got 1 mole, 44.01. Okay? What am I then dividing by? Which is 12.01. So 6 times 44.01 divided by 12.01. What does that give me? So 21? That's a really easy... Stop. 21 is fine. Why? Doesn't matter. Is it 50%? Sure is. Y'all good? Let's go on to the next one. According to the reaction above, what mass of oxygen is required to produce 22 grams of carbon dioxide? I'm not even going to spend time on that question. What do you have to do there? Gram to gram stoichiometry. You're going from 22 grams of CO2 to grams of oxygen gas. I'm not spending my time on that. I can do it in my head if I need to. What's your mole to mole? 1. I'm multiplying 22 times 32 divided by 44.01. Do it in your head. Okay? You can start setting up the stoichiometry in your brain and see if it flows. Okay? All right, number 10. A certain hydrocarbon was found to have an empirical formula of CH3. Its molar mass was 30 grams per mole. What is the molecular formula? How much easier is this question than the other question we had? A lot easier. Because it says its molar mass is determined to be 30. That 30, is that the empirical mass or the molecular mass? That's the molecular. So does that go on top or bottom? Goes on top. What is the empirical mass? Okay, so it's 12 plus 3, so 15.04. 15.04. So what is 30 divided by 15.04? 2. So what is 2 times 1 times 2? Did you even need to write anything down on that? Do you see how I did it though? I mentally pictured. I've got a formula. I've got the mass of the MF over the mass of the EF. They told me this thing is 30. That's not hard to do. That's really easy. That's 15. 15 divided by 2 is that. Now just double everything in there. That's real simple. That's really simple. But that's where we're getting to. We're getting to be able to do those things. Now, remember at the very beginning I said that these kind of questions are no longer the test? I was wrong about that one. It's this kind, number 11. And I knew we would eventually run into it, where they give you these and you have to do things like this. These style questions are no longer on the test. Okay. As of 3 years ago. It's pace. Pace. Yep. Do you really need to spend 2.5 minutes on that problem? You need to spend about 30 seconds at most. Okay. All right, a student captures 0.5 moles of each gas listed in a separate evacuated flask. Which choice lists the flask in order of increasing number of grams of a gas? Now let me ask you something. If you have half a mole of every gas, does half a mole all weigh the same? Does 1 mole of everything weigh the same? You're 1 mole. Do we all weigh the same? Okay, if I took half of you, would it all weigh the same? Is that exactly what it's asking? It's asking you what half of all of this stuff weighs. What is half of H2? Well, that's easy. 1.01. What's half of O2? 16. What's half of Cl2? What's half of CO2? 22. Very good. Now, the reason I know this 22 is because CO2 is 44. Well, we need half of 44, right? All right, and then CO is 12 plus 16, which is what? 38. And what's half of 38? 19 and a half. No, there's just 19. Does that make it a lot easier? Now, let me ask you something. If I change this problem to 1 mole, is the answer still going to be the same? Yes. You know what? It's still the exact same answer. Half of 38. Oh, my bad. We said 38. Sorry. So it's, what'd you say, 14? That does change it, doesn't it? It does change it. Now, so here's the important part. What order are we listing these in? From in order of increasing numbers. So the far right has to be the most or the least. Increasing. That and I'm telling you, this is an easy question, but the way they word it can kind of throw you off a little bit because we're going from least to greatest. So what should be the far right? So the only answer choice is what? What answer choice is dumb as hell? Why is D dumb? None of those things are equal. You know what? You know who the people are who are going to make that answer choice? The people that said you have half a mole of each. Well, if you have half a mole, they all weigh the same. That's not true. If I cut every single one of you in half, would it all still weigh the same? Okay. That's right. That's like if you have a pound of feathers or a pound of gold, which one weighs more? If you have a pound of feathers and a pound of gold, which one weighs more? They are equal. Shh. Sir, depends on the size of the grain. Okay, Edward still hadn't figured this one out yet. Edward, I have a pound of A and a pound of B. Which one weighs more? A pound of A. Now, I have a pound of feathers and a pound of gold. Which one weighs more? They're the same. Yes. I don't know. Depends on STP. Depends on the pressure and temperature. Yeah. And the volume is solely dependent upon temperature and pressure. All right, let's look at 12. Guys, the more we do of these, the better you're going to do. 12. Which of the following statements is true about a balloon filled with one mole of S2O gas at STP? Ding, ding, ding. We have a winner, 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 chicken dinner. We already know this. No. STP is 1 mole, 22.4 liters, 273 Kelvin, and 1 ATM. Now, the great news is, did they actually give you 1 mole? If it was half a mole, what is the only thing that would change? Your volume is the only thing that would change. We cool with that? Why can't your pressure and volume change? Actually, never mind. So, which one of these do we know is definitely true? Definitely, because is it 1 mole, that many molecules? That is definitely true. So which ones can we eliminate? A, B, C. We can leave. So far, we don't know yet. We can. And guys, this is a test-taking strategy. I can't encourage you enough to find the wrong ones first and get rid of them. If you take it from that approach, it makes the test a lot easier. Now, on the new AP test and how my test is going to be, it's only 4 answer choices. 4 years ago, it was 5 answer choices. But what they have found is statistically, the tests are the exact same difficulty with 4 answer choices and 5 answer choices. Now, that blows my mind, but apparently, statistically, it's true. It's the same difficulty. Yes, there's going to be 2 garbage answers versus just 1. So, hang on. So, I want to answer this because we're almost out of time. So, now we've got to figure out the contents of the balloon would have a mass of 64 grams. How would you know if that's true or not? If you have 1 mole of SO2, how many grams is that? It's 64. You just calculate the molar mass, right? Okay, so now 1 is true, so that makes E correct. Yes. And that's not true. It would be the pressure as well. I did. Sorry. Nothing. Don't worry about it. That's fine. Which of the following is incorrectly paired? Guys, that is just you writing the formula and calculating the mass. I can't. That's basic. A student measures out 360 grams of theobromine, which is that thing. Hang on. The primary alkaloid found in chocolate. That's interesting. How many atoms of hydrogen? Hey, guys, real quick. This is the last problem because I want to do this because this is important. I want you to see this, okay? So, we've got... Just play nice. Oh, that's not right. No, I'm good. So, it's 360 grams of TB, and I want to know how many atoms of hydrogen there are. So I've got to go to grams to moles of TB, and then from mole, listen, stay with me, of TB to mole of H. That's theobromine. That's the name of it. Okay? And then from mole of H to grams of H. Now, 2 of them are really easy. This one they tell you, it's 180 grams in 1 mole, and in 1 mole we have 1.01. Trevor, this is the exact question you were asking me earlier. When do I just use H? Look at the question. How many atoms of hydrogen? Does that help? Now, here's the question. How do you get the mole of TB and mole of H? What is that called? That's the molecule to atom ratio. So for every 1 theobromine, how many hydrogens are there? There are 8. And then you would just run your math. It's not a very good 8. Okay? You got to. If you don't, you're screwed. Four. Meth is 1 carbon, and then ane is double carbon plus 2. CH4. Go ahead. Question. Ask me. Say it again. Oh, wow. Thank you. I totally messed this up. Thank you. This is not grams. That was supposed to be atoms. Thank you for catching that. So instead of 1.01, it's 6.02 times 10 to the 23rd. Thank you for catching that. You are absolutely right. I just went to grams. Yeah, that was way wrong. My bad. Theobromine. It says the name in the thing. Student measures. It's abbreviated theobromine. Instead of writing this formula right here, I just abbreviated it. Look, there's the formula right there. Like glucose is C6H12O6. Theobromine is C7H8N4O2. Does that make sense?